Okay, so now we are going to solve two examples from the book, Giancoli 6th edition, which are the example 19.4 and 19.5. Okay, so it's a circuit. We want to find current passing through this circuit. So the circuit is the following. We have a battery. So let's try to make this drawing here. We have this battery here. The battery, the potential difference is given is 12 volts. Then we have first one resistance here. This resistance is 400 ohms. Then it splits. Okay, we'll have now two resistance in parallel. One is 500 ohms and the other one is 700 ohms. And then we get together again and close the circuit. So this is the circuit that we have. Okay, we have all these resistances, we have the battery, the potential difference, and we want to know how much current is drawn from the battery. And so we want to know what is the current that is drawn from the battery. Okay, so how are we going to solve this problem? The first thing to do is to try to find the equivalent resistance of this circuit. If I have the equivalent resistance from this circuit, then it will be easy because I will just need to use this equation to find this current. Okay, so what I'm after here is I want to substitute all of this resistance by a single one, which is the equivalent resistance from this whole circuit. Okay, now the issue here is how I'm going to find this equivalent resistance. I have a mixture of scenarios here. I have these two resistances here, the 500 and the 700 in parallel, and these ones are in series with this 400. So I have a mixture of things. How can I find this resistance, this equivalent resistance? Once I have it, I'm done with the current. So I have to go step by step. So the first thing that I'm going to do is I'm going to try to simplify this circuit with the first resistance that I'm able to find. So what I'm going to do is I'm going to eliminate this resistance in parallel. So here I have the 400, and now instead of putting that drawing with the parallel, I'm going to try to substitute this one with a resistance for that parallel piece. Now the equivalent resistance for that parallel piece, the piece that involves the 500 ohms and the 700 ohms. So what is the equivalent resistance for this piece of my circuit? So what is this RP that I'm calling this equivalent resistance for that piece? So the equivalent resistance, I will, since it's in parallel, it's going to be 1 over R, that P that I'm calling, equals to 1 over 500 plus 1 over 700. So if you solve this, you will see that this equivalent resistance, just for that green piece there, is going to be 290 ohms. Okay, so I simplify my circuit. My circuit now is involving just two resistance. One is 400 ohms and the other one is now 290 ohms. Okay, now I still haven't got the equivalent resistance for the whole circuit, but now this looks much easier because what I have here remain is just two resistances in series. So I know that the equivalent resistance is just the sum of the two. The current has to pass through these both resistance. It has no place to escape. So these two resistance have to add up. It's going to be 400 plus 290 will give us 690 ohms. All right, so now I'm done because I have the resistance. So I'm going to come back to this equation and find the current. So the potential difference is that 12 volts that was given to us. The equivalent resistance is 690 ohms, and now finally I can get the current. Okay. If you solve this equation, you will see that the current is approximately, let's write it here, it's more or less, it's approximately 17 milliamps. All right, So coming back, what we did was to simplify the circuit. Instead of having these three resistances, we looked for the equivalent resistance. So we started from the piece of the circuit for which I could already find the resistance, the equivalent resistance, which was this green one. So I found the equivalent resistance for this piece. This is a parallel circuit. No, this 500 and 700 are in parallel. So I used this equation to find the resistance. And then what remained were just two resistances in series. I just had to add them up. With the equivalent resistance, with this final circuit here, I can then find the current that goes through the whole thing, not the current that is drawn from the battery. Very well. Now comes another question, which is, what is the current that goes through just this resistance 500? So let me erase all this. Let's just remember that the whole current was 17 milliamps, right? So I'm going to erase all this. And now the question is, what is the current that goes just through this piece here? Okay. So what is this current? I'll call it current 1. Okay. So how are we going to find that? Let's think a little bit. What do we have? This current, the red one that we have here, is going to pass through this resistance. There is no other way for it to go. And then once it passes through this resistance here, it will split. Part of it goes to 500 ohms and the other part goes down here to the 700 ohms. So the current I splits. How can I find this piece here, the current that goes through the 500 ohm? Well, if I had the potential difference for this piece, I would be done. No? Because if I had the potential difference for this resistance 500, I would just use this equation here and I would be able to find the current. So you see that what I need to find is the potential difference. So let me try to make this circuit a little bigger to explain what we have. So here is the high potential of my battery. I'll call this point here VA. Okay. And this is VA throughout, because this resistance along the wire is very small. So all the way to here, I still have practically VA. Once I pass through this resistance, I have a drop. Now my potential drop and becomes VB. Okay, then after this point, I have the splitting of the current will split into these two pieces. Will split, has to go through this whole thing and then comes back. And after that there is nothing else. So everywhere here I have pretty much the same potential, which I'm going to call VC. Okay, so you see that for this part where I have this parallel, these two resistances in parallel, the potential difference is VB minus VC. Okay, so what is the potential difference VB minus VC? Well, what we have is the whole potential difference is VA minus VC, right? So this is the potential difference of our battery. I can call it just V. Then I have this potential difference for this first resistance, 400 ohms. So this is the VA minus VB, which I can call, for example, V prime. And then we have the potential difference between VB and VC, plus VB minus VC, which I can call V2 prime. Okay, so the whole potential difference given by the battery is the sum of the potential differences in all of the pieces along the circuit. Okay? So what is important for us here is that the potential difference for this resistance 500 ohm is this VB minus VC. This is the same potential difference for the resistance 700 ohm. Remember that when we find two resistances in parallel, they are subjected to the same potential difference. What happens is the current splits, but the potential difference is the same. Okay, so the potential difference is VB minus VC. No? So it's VB here, VB here, VB here, VB here, VB here, VB here, and it's VC here, VC here, VC here, VC here, VC here, VC here. So the potential difference for the resistance 500 is the same as the potential difference for the resistance 700. Okay, the potential difference for the battery, I know it was given to us. Now this one here is just 12 volts. Do I know the potential difference for this resistance, for the resistance of 400? I do know, because this potential difference is just the current that goes through it and multiplied by the resistance. So the resistance is 400 and the current we found, right? The current is approximately 17 milliamps. If I put the correct value here, I have 0.0174. Okay, and then the VB minus VC, which is the potential difference for the resistance 500 and 700, is the one that I don't know, but now I can get. Okay, so from this equation here, I'll be able to get the potential difference for this part of my circuit. Okay, so this one 400 multiplied by the whole current is approximately 7 volts. Okay, so all that to conclude that the potential difference VB minus VC, which is the potential difference for the resistance 500, is equal to 5 ohms. All right, now with this I'll be able to find the current that goes through the resistance 500 ohm. How? I'm going to use this equation, V equals to RI. The V that I'm interested in is the VB minus VC, because I'm thinking about the resistance 500. So this is 5 volts. The resistance I have, the resistance is 500 ohms. And from that, I will finally be able to find the current that I'm after, which is 0.01, 0.001, no? So it's 10 milliamps. So you can do this calculation. Okay. So again, let's repeat the story. The potential difference goes on. The potential drops every time I go through a resistance. So it dropped here, and then it dropped again from B to C. These two resistances in parallel, they are subjected to the same potential difference. The only thing that we have here is the splitting of the current, but the potential difference is the same.